Morning, guys. Happy Monday. Good morning, Rachel. How you doing? How was your weekend? Morning, BC. Looks like maybe two people are here. Go ahead, let me know if you're sitting in the chat right now. Happy Monday. This is a big week for AP test. My brother came up from Columbus to visit, so it was good. But we talked till 3:30 this morning, so I'm very tired now. It is cool though. It's cool you got to see him. Yeah, I've had those nights where my brothers have visited and we've stayed up all night talking. Well, good on you for waking up and attending the live stream at 9 in the morning. I appreciate it. That's cool though. I'm glad you got to see him. Oh man, I'm tired too. I didn't stay up talking to anyone until 3:30, but I just couldn't really fall asleep. So I don't know what time I ended up falling asleep. Probably around 2. So I'm a little sleepy too, but whatever. Fight through it. Also, didn't realize the 2016 FRQ was due yesterday, so can I still? Yeah, absolutely, Rachel. I honestly, if today, just focus on whatever you got to do to prepare for the test tomorrow. If part of your preparation is to finish that FRQ, then by all means, you can do that. Um, yeah, I don't mind. Any late work is fine for me. So I don't care if you do it today, if you do it Wednesday, if you do it next week. It's not really important. As long as you get it to me at some point, you are good. But I mean, it's a good way to review your material anyways. So it's not the worst thing to do if you feel like you're comfortable with everything else. Let me see though. If Rachel, is that opened up or is it actually closed on AP? Because I would prefer it if you turned it in on College Board. But if it's closed, I guess I can check real quick. Just gonna take forever on my internet. So I'm really upset this morning. I got an email, and it was from Cleveland State, And so I've been using my college email, which is just a great like email to use. I got a lot of stuff set up from college from to there, but also I just use like anything that I put like I don't know. I guess so, like I have like a personal email for like Gmail, and then anything I want more professional, I would send my college email. And I kept doing that, and it was a good process. It worked for me. You know, didn't have very many emails going there, but the ones that did go there were important. I had to look at. Anyways, I got an email from Cleveland State today saying that email is being canceled, which stinks because I was under the impression you had it forever. I don't know why. At some point, I thought I was told that, and apparently it's not true. So it lied to me, which is pretty frustrating. So now I gotta reroute and probably make myself a new email. And I have to take, more importantly, I have to take all my information from my college email and transfer it over to this new email, which is going to be a real pain in the butt. I'm not looking forward to that. Oh yeah, we did do it through Google Classroom. Good call, Rachel. I forgot about that. Yeah, it's not on College Board, which is perfect because then I don't have to open anything up. So yeah, just turn it in late. It'll give me a notification said Rachel Miller turned this in late. Whatever. You're not getting any points off for it. So for this, the 2016 FRQ, honestly, it's gonna just be completion. I'm just gonna like glance over the work just to see that you guys put effort into it. I'm not gonna grade it for accuracy because by the time it's done grading, it'll already be, you guys will be done with the test anyway. So my feedback isn't particularly gonna be useful. So I'll probably just I'll scroll through it, make sure you guys did it. Looks like the work was good, and that'll be it. So all right. So Rachel, you're the one talking. It looks like I have two people. I don't know. I don't know who else is here. I don't know if it's sometimes my viewers are just like numbers I don't really understand. Either people just don't talk, or it gives me the wrong number of viewers for some reason. I don't know. But regardless, I guess I'll ask if there is someone else there. If not, at least I'll ask you, Rachel. Before I get started on kind of what like my plan was, I guess, for today, based off of the feedback I was given, is there anything in general you want to talk about? Anything with the test? Anything? Any questions about how you to prepare for it? What to do when the time comes? Um, any like maybe general content questions? So I'm gonna take the beginning of the class just for that. So I'm opening it up to you. Anything general, not like specific question types, because I already kind of got feedback on that. Just in general on the test. God morning to you too, Liberty. All right, so I got more people. That's what I'm talking about. Liberty said I don't have any general questions. Okay, cool. Thank you. How are you, Liberty? How was your weekend? Everything going good in your world? Oh, by the way, congratulations on the opportunity to participate in the speech and debate internet or national. I think over online. I read it like really quickly in a tweet that you guys are still going to do it. I don't know, virtually, I guess, but congratulations. That's really exciting because I know that was a big bummer. You guys were looking forward to that, defend the title, but now you get to. It's awesome. Everything has been all right here. Thanks. Curious about how it'll play out at nationals. That is very interesting. I mean I've never been to obviously the real event. I don't know what it looks like or anything, but I know it's nationals and there's probably a lot of people. So I don't know how on earth it's going to be done over the computer. But hey, at least it's cool. It's a cool experience. And it'd be even awesome if you guys win. You can say like, hey, we won the weirdest nationals to ever happen. You have that bright. You won normal ones and you won quarantine edition. It's a pretty cool. That'd be a pretty cool accomplishment. Put that on my resume. Rachel, I see either you're typing or you're ignoring my question. Are you good with? Do you have any general questions? Or are you okay? I've tried to be as specific about all the details, and I know all your other AP teachers have been too. So hopefully, with all of us combined, you've gotten every piece of information drilled into your brain because we've probably all been bothering you about it. And knowing you guys were responsible. You've probably been doing any research that you needed to before today to figure out any misconceptions. No, you're fine, Rachel. I was just giving you a hard time. Don't have any. Okay. All right. Very cool. So I didn't think about this when I made the poll, but it kind of dawned on me after the fact that I realized I gave the poll to AB and BC, and then I realized, well, BC is going to be just YouTube probably, maybe Hunter and maybe Cole, we'll see. But I figured I was like, I'm not going to know what those two said, so I was like, that wasn't a really good idea. I probably should have mentioned to put your name down, but I think luckily I'm just making the assumption you two filled it out. And both of you guys put series somewhere in there, so that kind of helped. That was so I knew like, okay, those are my BC students. So that helped me kind of narrow it down. And the consensus was differential equations, series. I guess just some different forms of series, Taylor series specifically. So Taylor series, differential equations, and then someone said partial fraction decomposition. And I decided I really couldn't even find any free response questions. So my plan I went through a bunch of old AP exams. So I just went through like, I don't know, 2005 to like 2015 AP exams, and went through all the FRQs and just try to find, okay, what would be useful to go through. And partial fractions just is not on there very often. So with that being said, I don't think with them only having 2 questions this year, that's going to be the most useful thing to review. I would venture to say the odds of it being on there are pretty slim. So I'm not going to take time on that one. But I will do, for the next 45 minutes, my plan is to do 2 free response questions. One that has differential equations, and then one that has series in it. So that's my plan. Rachel, you put on your calendar for this week. You're supposed to crush the AP calculus. Oh, I know. Dang it! I meant to change that too, because I did that. It's the same thing for AB. I guess you guys are taking, actually, we're going to be, half of your exam is going to probably be AB questions. So I'm not entirely wrong. I'm also not right, but there's going to be AB parts on there. I'm going to change that right now. It's super important that I get that fixed. All right. Yeah. Okay. So differential equations, Taylor series. That's what I want to start with today. So the first one I want to do on Google Classroom, I posted 2 different FRQs. One of them was 2005. One of them was 2011. So I'm going to start with the 2011 FRQ. So I want you guys to get that up, open on your computer, and go to question 5, and then just type in the chat when you're there. And I need to go get tissues. Ready. Okay, perfect. So, let me ask you guys, what do you think would be more beneficial? My plan was to have you guys, like we usually do, go through and then see how you feel, get as far as you can get, and then we'll review it as together. Would you guys prefer that, or do you want me to walk through each step? What would you guys like to do? Okay, cool. So you guys need to go ahead and start on that one. Um, See if you can do in like 15 minutes. That's my goal. So just like an AP test by 9:30, 9:31, somewhere like close to there. Let's see if you guys can get this problem done. So time starts now. Go ahead and dive in. So guys, about maybe 35 minutes. Let me know when you're done. If you finish a little bit earlier, just type in the chat that you're done. Nice, Liberty. All right. All right. Nice. Good timing then. Okay. So I will talk about the answers first. And then I can clear some stuff up. So when I go over these answers, I'll kind of describe it, and then let me know how you did, and if not, if you need to go over any of them, you can. All right. So this question says, beginning of 2010, a landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at landfill. Planners estimate that W will satisfy the differential equation dW dt equals 1 over 25 times W minus 300 for the next 20 years. W is measured in tons and T is measured in years from the start of 2010. All right. So you can see pretty clearly off the bat we have a differential equation. We're given a derivative. It's usually a good sign. Use a line tangent to the graph of W at T equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010, which is when time T equals 1/4. So we don't have to do any sort of manipulation with the 3 months part. It just tells us just use T equals 1/4. So we're using the line tangent to the graph of W at T equals 0. Now, we've seen problems where we're given the original function, and then we're asked to use a tangent line to approximate a point. And so it says use the equation of tangent line. So what we'll do is, we'll find the derivative first, and then we'll plug in whatever point we're looking at to get the slope, and then point slope form, and we're done. This problem's different, and we know we can do it. We have to do something different, is because we're not given we're not giving W. We're given dW dt. We're given the derivative. So if we're going to approximate a tangent line when we're given the derivative, what we do is we use our linear approximation formula, or tangent line approximation formula, whatever you want to call it. So you had to use that, which was, if you guys remember, and there's a couple ways you can write it, but basically it's L of x, so your linear approximation of x, is equal to, in our case, W of A plus W prime of A times T minus x. Or T minus A, sorry. So what we want to use then is at 0. We want to use the linear approximation at the point 0, which means that we've got to find W of 0 plus W prime of 0 times T minus 0. So W0 we know, the initial condition is 1,400. So we know that W of 0, they tell us at time 0, the landfill contained 1,400 tons of waste. So if it's 1,400 plus W prime, you would just plug in 0 into our derivative. In this case, right, you plug in 0 into our derivative for T. Well, there is no T, so we're not really too super concerned about that. And so after you get that, you simplify, add them together, and you end up getting 1,400 plus 44T. All right, 1,400 plus 44T. And then to actually get the approximation, we just plug in 0.25 into T. So that's our formula to approximate it. Then we can use that to approximate whatever T we choose. In this case, the question wants us to choose 1/4. So we try 1/4, plug it into our calculator, and we get 1,411 tons of waste, or 1,411. All right. B, second derivative. So second derivative is pretty easy for this one. My recommendation would be to distribute 1 over 25. So what I would do is I would distribute 1 over 25 to w into 300. After you distribute it to w and 300, then just take the derivative of that. And so once you get the second derivative, you get 1 over 25 times w prime. So that's the mistake people make a lot of times. Remember, it's with respect to t. So when you're taking that derivative with respect to t, you got to use implicit differentiation. So you get 1 over 25 times w prime. To actually solve for that, you would just replace w prime with what was given to us, with our derivative. And you end up getting, you didn't have to simplify depending on what you guys chose to do, but something like this, w minus 300 divided by 625. That's what it would simplify down to. Whether you did that or not, that's really not too important. And then if you want to get, the actual question said to find the second derivative in terms of w, and then use that to determine whether your answer in part A is an underestimate or an overestimate of the amount of solid waste. So what we want to check is concavity. That's what the whole point of getting the second derivative. It's giving us concavity. So we find that at 0, at time 0, it's going to be concave up. So you plug in 0, it's going to be concave up, which means that w of 1/4 is an underestimate. Whenever you have a concave up curve, you're always going to be an underestimate. Whenever it's concave down, it's an overestimate. I kind of like think of them as like opposites. All right, and then the last part, C, is separation of variables. So the question said to find the particular solution to differential equation with initial condition. That kind of format of a question is always leading towards separation of variables. So what you want to do, again, distribute the 1 over 25, and then separate the w onto one side and the t on the other. So in this case, actually, you know what? I take that back. Don't want to distribute. Just divide by w minus 300, and keep the 1 over 25 on the right side. So you'll get dw divided by w minus 300 equals 1 over 25 dt. And then use separation of variables. So you're going to take the integral of both sides, and then you're going to isolate w. So you're going to natural log. You have to take the natural log. You have to take e to the both sides. Add 300, and your final answer for C will be 300 plus 1100 e to the 1/25th t. All right. How'd you guys do? All good here? Nice. Good job, Rachel. So the good thing, too, is you guys seemed like the timing was good, which is awesome. So I don't know if when you guys have been practicing, if you've been practicing the time at all, but I'm very happy it looks like you guys get that through. Oh, Liberty did the wrong FRQ. Liberty, which FRQ did you do? I can go over the answers for the one that you did, if you would like. And then you can just check that one. That's not the worst thing in the world. Oh, you did 2005? Oh, man, I'm sorry. I know I said it probably pretty quick. I was hoping that on my screen, the 2011 part would give it away. That's okay. I'll tell you what. How about I give you the answers for the 2005 one? You might as well. If you put the effort in, you might as well. I was brushing my teeth when you were giving directions fairly zeroed out enough. That's okay. Hey, Larry, you can just go back and it'll be extra practice. You can go back and do the 2011 number 5, and you'll have the answers and everything. It'll be good. So might as well. Why don't we just go over that one then? Let me see if I can get my answer sheet out. All right, so Rachel, if you want to open up 2005s, I'll try to talk it through. And then, Rachel, same thing with you. If you want to actually work it out and check your answers after the fact, feel free. And I'll go over that now. That's fine. No big deal. So again, question 5 is also in Google Classroom, so you can check that out. I understood it all, so just some answers would be fine really quick. Okay, no worries. All right, so for A, wanted to find the integral velocity. You get 360. Using correct units, it'd be 360 meters in those 24 seconds. So 2005 5A is 360 meters. B, v prime of 4 does not exist because the limits, you just use the definition of continuity. And you'll see that the limit as t approaches 4 from the left is equal to 5, which is not equal to 0. And 0 is equal to limit as t approaches 4 from the right of the average rate of change. And then v prime of 20 is equal to negative 5/2 meters per second squared. Negative 5/2 meters per second squared. C, you want to write a piecewise. So you can see this is broken up into the graph was broken up into 3 different lines. And you want to get an equation or an acceleration, I guess, not even an equation, an acceleration for each of those lines. And to do that, the first one from 0 to 4, that first line, your acceleration should be 5. From 4 to 16, it makes sense the velocity stays the same, so your acceleration should be 0, right? That makes sense. So 0 for 4 to 16. And then from 16 to 24, you can see it's going down, so you know it's going to be negative. In this case, it's negative 5/2 from 16 to 24. A of t does not exist at t equals 4 and at t equals 16. So remember, if you have a abrupt change in your graph, that means that the derivative does not exist at that point. All right, and then the last part was part D. Part D was find the average rate of change and use mean value theorem. So to do that, you take v of 20 minus v of 8 divided by 20 minus 8, which is negative 5/6 meters per second squared. No, the mean value theorem would not apply on v because, like I said in the part C, v is not differentiable at one of those portions. So part of the mean value theorem, in order to use it, it has to be differentiable on the open interval and has to be continuous on the closed interval. Hopefully I didn't mix those up. So in this case, in the middle, smack dab in the middle is 16. It's not differentiable there, so it definitely isn't differentiable on the open or closed interval, which means nope, can't use it. All right, no problem, Liberty. So yeah, Rachel, if you want to, go ahead and knock yourself out if you want to try that one. Extra practice, you got all the answers right there. Perfect. Okay, so well, this is a good transition then. Here's what I want you guys to do. We got 20 minutes left. How about take 15 more minutes? Think you should be able, 15 minutes. Let's do 15 minutes and do question 6. So from the 2005 FRQ. 2005 FRQ. Number 6. So this will be a Taylor polynomial Taylor series question. So we'll throw one of those in before the stream is over. Hit 2005 cat. Right. My time to shine. You just really want to do 2005. I get it. Calling your name. So same thing as last problem, guys. If you guys get done earlier, let me know. So if you're both done, then I can start going over it quicker. Are we supposed to write the general term for b? Yes, exactly. So that's when it says the coefficient of x minus 2 to 2 to the n. That's for an nth derivative, so it needs to be a general form. So no matter what n is, you can get the answer. Since we don't have a lot of time left, would it be okay if we just went through all the process now? I'm not on part by one. Yeah, absolutely. I kind of figured as much too. All right, so to get a head start, because like you said, Rachel, I don't want to make sure that we do get this through in time. You guys can check your answers for A and B on my paper right now. So I'll talk about this, but just take a look at it. So I didn't want to say the whole thing for A, so I just wrote it all out, and then B as well, kind of the process. So I'll get started talking. If you got both of those right, fine. Just keep working on whatever problem you're on or part you're on. So not too much information is given to us. All right, we're given f of 2 equals 7. We're given that when n is odd, the nth derivative is 0. That's important. And then when n is even, the nth derivative is given by what they give us there. So part A just says to write the 6th degree Taylor polynomial for f about x equals 2. So just remember the general form of a Taylor polynomial. All right, it's going to be, in this case, f of a plus f of n of a. In our case, this n would be the first derivative, times x minus a. Well, anytime the number derivative is odd, it's going to be 0. The coefficient will be 0. So if you guys figure that out, you could have just kept doing every single thing, but you would have found that every single odd coefficient, every odd derivative coefficient was always going to be 0. So you could just ignore all odd derivatives. So we start with 0, and then we go to 2, and then 4, and then 6. Okay, so that's where those kind of parts came from. And then to get the actual coefficients out front, we just use the formula that they give us, f to the n of 2, and then divided by whatever n factorial was. So if it was the second derivative, it would be 2 minus 1 factorial divided by 3 squared times 1 over 2 factorial. If it's the fourth, it'd be 1 over times 1 over 4 factorial. So you're just replacing n with whatever nth derivative it is. So there's not really much work I can do. If you want me to explain that in more detail, I'll do that if we have some time left. But there's not really too much more I can do for that. Really, the focus is just the concept of a Taylor polynomial and the setup for it. All right, so 6b says, in the Taylor series for f about x equals 2, what is the coefficient of x minus 2 to the 2n for n is greater than or equal to 1? Well, we know that the general coefficient for x minus 2 to the n, because that's what we did in the part before. If you guys notice up here, look at each of these. That's x minus 2 to the n. That's the second derivative, n is 2. X minus 2 to the n is 4. X minus 2 to the n is 6. So to find the general coefficient for all of those, we use this idea. The n minus 1 factorial, which was given to us, divided by 3 to the n, which is given to us. But we know for a Taylor polynomial, the coefficient includes being divided by the factorial of whatever number coefficient you're on. So in this case, divided by n factorial, your nth term. Which means if we want to find the general coefficient for x minus 2 to the 2n, what changed from here to here? Well, we multiplied, or we squared it. We raised it to the second power. So everywhere I see an n, I'm going to replace it with 2n. So instead of n minus 1 factorial, it's 2n minus 1 factorial, 3 to the 2n, and then instead of n factorial, it's 2n factorial. I can simplify this because 2n factorial is 2n times 2n minus 1 times 2n minus 2. 2n minus 1 factorial is 2n minus 1 times 2n minus 2, and so on. So everything is the same of these two, so you can cancel out every term except for that 2n in the denominator. So that's where you get that from. Now, I want to talk about this now before C. It's really important that we understand at B what that was just doing. Like, why did we do this? Why did we change this? Why did we go from just an n to a 2n? And the reason we did that was because there is no point of doing n because half of them, meaning all the odd nth derivatives, are just going to be 0 anyway. So why are we even looking at those? If we raise it to the second power, or we make n 2n, so 2 times n, it'll always be an even number in this case. Right? Because any number times 2 is going to give you even. Any multiple of 2 is an even number. So the reason why they had you do part B was because they wanted you to see what would be a way to find only the even coefficients. How can we make our lives easier by just finding what the even coefficients would be? So that would be your formula for that. Part C, I'm not going to go through, so let me just say what it is. It's going to be find the interval of convergence of the Taylor series for f about x equals 2, show the work that leads to your answer. So the general outline I'll write down. So the general outline of the Taylor series is going to be f of x is equal to f of 2, which is 7, that was given to us, plus the series, when n equals 1, of our new formula we just found. So 3 to the 2n times 2n times x minus 2 to the 2n. Again, we're doing that because we are only focused on the even values. We have to include the 7 out front because n starts at 1. All right, so we have to include that 7 out front, which is representative of 0, f of 2, or the 0th derivative, I guess. So the question wanted us to find the interval of convergence for that series, which means that we have to go through and use the ratio test. Because I only have 3 minutes left, I don't have enough time to do that. I'll let you guys do that on your own. What you end up getting is something like this. So you have x minus 2 squared divided by 9 times the limit as n approaches infinity of 2n divided by 2 to the n times n plus 1. This is going to go to 1. This limit goes to 1 right here. So that means we're going to have x minus 2 squared divided by 9 times 1. And our interval of convergence means that has to be less than 1. Make sure you guys can see this. Yep. Okay, and then we're going to keep manipulating this. So x minus 2 squared is less than 9 if I multiply 9 to both sides of that inequality. And then if you take the square root, that means the absolute value of x minus 2 has to be less than 3. The absolute value of x minus 2 is the same thing as negative 3. It has to be less than x minus 2, no absolute value, which is has to be less than 3. Add 2 to both sides, you get negative 1 is less than x, which is less than 5. Now, I remember you two do a pretty good job of this. The other two gentlemen that aren't here, of course, they don't. They forget this a lot. You'd think you guys have a pretty good understanding of this, though. This isn't it. And they might say this. Let me see what the question asked again. Okay. Yeah, so they don't really give you any hint either. So you guys have to just understand that this is a great start, but we have to check the endpoints. And that's going to be worth points. So that's like if you did all this work, you got 3 out of 5 points. But to get 5 out of 5, you still have to go. You have to consider both these endpoints. So you're going to take your original f of x. So this right here, you're going to take that, and you're going to evaluate this series when x is negative 1. So you'll plug in negative 1 for x, and when x is 5, you'll plug x for 5. And what you'll find is both of those series inside this part, so this series part right here, will turn into a harmonic series once you do some simplification. And we know harmonic series diverge. So you're going to find that at both endpoints, the series divergent, meaning that this actually does end up being our final answer. But I don't care. If you don't evaluate at the endpoints, then you're not going to get full credit, even if you did put the right answer. Because they need to see the work you put in to evaluate at the endpoints. And they need you to say it's divergent because of the harmonic series. I know I kind of ran out of time, so what I plan on doing, BC, is posting solutions to these 2 assignments. And then you guys can do more questions to practice if you want, to prepare even more. And at the very least, you can see the work and match up your work even more. All right, well, BC, before you guys go, specifically, I guess, Liberty and Rachel, before you guys go, thank you again for showing up. Hopefully this was useful. Hopefully this was helpful to you. I will be at office hours 1 to 2 today. I will be answering any emails throughout the day. So please don't hesitate. Email me any questions you got while you're studying. Even if it's tonight, as long as it's before 9 o'clock, I'll try to answer any questions you guys have. So if you're working on something and you're really struggling, or you're just reviewing and you're like, I don't get this concept at all, go ahead and email me real quick, and I'll see what I can do. It's not the same because I'll have to talk over, message, but we'll figure it out. So just don't hesitate to let me know. I won't talk to you if you don't reach out to me. So if not, I wish you two the best of luck tomorrow. You guys are going to do great on it. Feel very confident. Just, don't stress yourselves out. Just take it easy. Just do some last minute stuff, some last minute maintenance to get ready for it. So best of luck to you two. Good morning, Haber. AB, good morning, good morning. Let me show my face. Good morning, everyone. How are we doing today? Good morning, Peyton, Andrew, Barron, and Jasmine. How was everyone's weekend? Anyone do anything cool? Anyone do anything fun? Something they want to talk about? I'm sure a lot of your weekend was studying for AP stuff. I believe the government test is today. Is that juniors who take the government test? So is that like all you guys who are taking it basically? Yes. Okay. Well, good luck. Your first AP test, knocking it out. I think it's at 4 o'clock, right? Yes. I appreciate you stopping in on the stream because I know you guys are probably thinking about that test and preparing and studying for that. So can't imagine that entire government class. That's pretty difficult to complete in 2 free response questions. So I don't know how you guys are going to predict what's going to be on there. I'm sure you'll be good though. Let's just be a quick hour review. Then you guys can get back to studying for government if you need to. So I'm just gonna get started now, just to give ourselves time so I can go over stuff and not really freak out or panic. So in a second, what we'll do is we'll talk about the survey I gave out, and I think 9 total people. 2 of them were from BC, so 7 total people of you guys answered it, which is good. It gave me some feedback. Wasn't enough feedback where I could definitively decide what we all needed or wanted, but I decided, I took the executive decision and chose what I think was going to be the most useful. So that's what I did, and that's what we'll go over. But before we do that, I want to ask you guys just in general questions you have. So not content-wise, not like topic-wise, just in general for the AP test. Things to study for tonight, things to do for today to prepare, maybe some nuance about the test you want to double check on, you're not sure about, anything related to that, like some maintenance issues, I guess. If you guys have any questions, general questions like that, please go ask now. If you're not, just go ahead and say good in the chat or something, like if you have no questions, so I can kind of get a consensus of if anyone's curious. I know like you've been inundated with a bunch of AP stuff from all your teachers. I know those of you who are in stats, I know there's not many of you, but a couple of you who are taking AP stats. I know Mr. Snook's been releasing a ton of information. I know Miss Graves, if you have her, she's been giving out a ton of information. I know I have, so you guys have probably been exposed to all things, everything about AP, as long as you're looking at it. All the resources that are out there, so good. Okay, cool. One thing I want to make very clear, and I'm going to say this because it'll also be useful for your, maybe not though, for government. I was going to say, make sure that for my test, you got to title your pages. So do that the night before, or at least tomorrow. Do it like tomorrow morning. Give yourself time. Like, don't wait till the test to like put all the stuff you need to put at the top of your papers. Do it well ahead of time to prepare. I forget exactly what that is. I don't want to tell you anything wrong. I know it's your AP ID number, the page number, and then your initials. I think those are the 3 you have to put on every single page you submit. Every single page you take a picture of, and they need to see those 3 things. So, like I said, have that done ahead of time. Don't wait. Do it ahead of time, so it's already ready. You're already ready to go. Give yourself 5 pages per question, and then just use what you use. So, like, get a notebook, like a notebook here. This is first page. Do a second, third, fourth, and fifth, and that's all for question 1. And then you'll probably only use 1 or 2 pages. That's fine. And then do the same thing and do it 1 through 5 for your second question. So that'll be question 2. That would be my recommendation. Do that ahead of time. You should have already gotten your e-ticket. If you didn't get your e-ticket, that's an issue. We got to talk about that. I don't know that. I don't foresee that happening. But if some crazy reason that happened, not good. We got to figure that out. So you should have in your email, most of you, if not all of you, your school email should have an AP email that gives you your e-ticket. Don't use the one for calculus for government today and vice versa. So make sure before you click on any links, before you click on any e-ticket, you clarify that it is government's for today and that mine or the AP calculus one is for tomorrow. So be very, very specific and try not to mess yourself up. Okay, so that's just a couple things I wanted to address real quick with you guys because I know this is your first time taking it and everything. So now's the perfect time then. Let's get started with some content because I know that's what you guys are here for. You want to get some last second review in. Now, here's the consensus. Now, again, there wasn't really any way for me to get like a clear cut, like this is what everyone needs. So I had to just take the data and pick and choose what I thought was going to be the most useful and try to vary what I did. So the two of the biggest responses I got were differential equations, integrals. Those were the two main ones I got, the two big ones. I also saw a lot about Riemann sums. Now, those are included in integrals. I shouldn't say a lot, by the way. When I say a lot, I'm saying like maybe 2 or 3 people responded with it. So like that was considered a lot in the survey. If 2 or 3 people said the same topic, differential equations and integrals, I saw 2 or 3, maybe 4 times, so I figured those would be good. The Riemann sums, that's going to be something that's useful for sure. I could definitely see a situation where that's going to be on the test. All right, so I'm not saying to ignore that at all. I would definitely still review. But since I only have 50 minutes to do something, I chose 2 topics. That'll be enough. And I chose differential equations and integrals because I think those are going to be the 2 topics that I'm very confident you'll see. And also they're more conceptual concepts. The Riemann sums is going to be like a part A. It'll be like, question 2, part A. And let's say you have no clue what you're doing. That's like, it's not good. You'll get 0 points or whatever, but at the very least, it's only just the one part. If you don't know what a differential equation is, the entire question could be revolved around it. So if you don't know that, then you're going to get the whole question wrong, just like an integral. Integral can determine like 6 different questions on this AP test. If you don't know anything or you have no clue what an integral is or if it's confusing to you, that's another thing that you could bomb your test based off of that. So I figured those 2 were going to be more valuable than taking time for the Riemann sum. So those of you who said Riemann sum, I apologize. I know we've done a ton of stuff with Riemann sums. We've really done a lot with Riemann sums, so please go back and take a look at all the different assignments and stuff we've done with that. All right, so I'm going to stop talking. Here's what I want you guys to do. Open up your Google Classroom and open up the 2011 AP free response. So I posted a PDF that was 2011's free response question, and then go to number 5. When you're there, type in the chat, let me know you're there. So I'll put it, my hover cam, 2011 FRQ number 5. Make sure you clicked on 2011's FRQ. You should be on a question that says something about a landfill. Okay, perfect. Here's what we're going to do. I should have probably done this a little bit more in the past, but I know you guys really enjoyed kind of the process we were doing where I would just walk you through the questions. Today is going to be like our quick hitters, and I want you guys to try doing treat these next 2 questions we're going to treat like this was your AP exam for this year. All right, so what I want you to do for this question, I'm going to give you 15 minutes. So at 10:27, I'm going to stop the clock and then talk about this. So you guys have 15 minutes starting right now. Go ahead and try to do number 5, A through C. Go. Time starts. Tick, 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 tick. See what you can do. Use your notes. Use whatever you want. A through C. Try to get it done in the next 16, 15 minutes. Zach, it should be in Google Classroom. I think it's going to be like one of the first posts. I posted 2 FRQs to Google Classroom. I think this one is going to be the second one, maybe. But yeah, go to Google Classroom and go to our feed. Should be there. Yep. Yeah, no problem, Zach. Thank you, Zach. Appreciate the blessing. All right, if you guys get finished up, go ahead and type in the chat when you're done. Some of you might be finishing up now. Go ahead and let me know when you're done. About 3 more minutes, 4 more minutes. Thank you, Peyton. All right, guys, let's bring it together. So that was a pretty good, I guess, time in terms of what you'll see on an AP test. So kind of check yourself where you're at right now, how you think you would be doing, how you think you did on this question. So I'm gonna break it down. I'll talk about it first, and then we can decide how much we want to go through in detail about the questions. So, first question. I mean, you guys read it, obviously. You're given this landfill, and we're given a differential equation for landfill going into this, or waste going into this landfill. So we're given dW dt, and it talks about W a little bit. W is the total amount of solid waste. Part A says to use the line tangent to the graph of W at t equals 0 to approximate the amount of solid waste in the end of the first 3 months, which means when time t equals 1/4. So we want to use a tangent line. Now, what we're used to doing is a lot of times we're given an original equation, and we need to create an equation of a tangent line at a certain time. And what we do is we take a derivative, evaluate that derivative at a certain point, that gives us a slope, and then use point slope forming an equation. This is a little bit different because we're going to use a tangent line to approximate. We're using a tangent line to approximate. We call that tangent line approximation or linear approximation. Linear approximation we have a formula for. So we needed to use a formula for 5a, which breaks down to this. It's basically L, in this case, of t. That's our linear approximation of t. We don't know what t is right now. We're going to get there in a second, but for right now, it's just going to be t. That's going to be equal to our linear approximation formula, which is saying w of 0, because we want a to be 0. That's the reference point, plus w prime of 0 times t minus a, which is 0. So t minus 0. All right, so that's what we got to find. All right, so let's break down even further then some of these pieces. So we know w of 0, that's given to us. Let me do it in a different color pen. So w of 0 is given to us. It's an initial condition. So when time is equal to 0, how much waste is in that landfill? And it's 1400. That was given to us. W prime of 0 is going to be equal to 1 over 25 times W of 0 minus 300. Okay, and then you have the option if you wanted to. So this was going to be equal to 1 over 25 times W of 0 is 1400 minus 300. So however you wanted to write this, if you wanted to actually get an answer for what that is, whatever you wanted to do, it was completely up to you. But basically, these are the two pieces of information we need. So if I'm going to find L of t, it's going to be equal to 1400 plus, I'm going to simplify this to 1400 minus 300 divided by 25. Remember, you're not supposed to have a calculator for this question, but on a test you'll have one anyway, so it doesn't really matter. And then times t minus 0, right? T minus 0 is just t. All right, and then what we want to do is we want to figure the L of 1/4. So when t is 1/4, that's the question actually asked to approximate when t is 1/4. So to approximate t, this is the equation we use. To approximate at 1/4, we plug in 1/4 for t. Don't think I need to go over that, right? And that's going to be equal to 1411 tons. So your final answer for A is 1411, or 1,411 tons. All right. B, we want to find the second derivative. So we take the first derivative, we take the derivative of that. This is with respect to t. That's really important. So the second derivative of w, let me back up. The first derivative of w is going to be equal to 1 over 25. I'm going to distribute that 1 over 25. So 1 over 25w minus 300 over 25. Sorry, Baron, I just saw you said something. Is there another way to do part A? Is there another way to do part A? I don't think so, Baron. Maybe. I just found the slope and plugged it into a point so far and got the answer. Doesn't matter. Okay. No. Yeah, that's the case. That's the only way I can think of. So when I found the slope and plugged it into the point slope formula. So we plug it into one, so we have the same answer. Yeah, I don't see an issue then. That's fine. I didn't really think about it that way. Sure, yeah, if that worked for you. I'm just trying to think of. Okay, that makes sense. So to find the actual slope. Yeah, okay, sorry. Yeah, you guys are completely fine. I don't know, I was overthinking it. Yeah, that also works. So guys, you could have actually done that. I just saw the word approximate and I went right into the approximation formula. Emma and Baron are correct. So for part A, you could have just evaluated what this is. 1 over 25 times 1400 minus 300. Use that as your slope, and then go into a point slope form. And that'll work. And then you would just replace x or t with 1/4, and you'd find what y equals. That was perfectly fine. Nice. All right, so for part 2, again, we want to break this down. The first part just says to find the second derivative of w. So this is the first derivative of w that was given to us. To find the second derivative, we use implicit differentiation. And this becomes 1 over 25 w prime. And this is a constant derivative of constant 0. So the second derivative is going to be 1 over 25. We know what w prime is. It's 1 over 25w minus 300 over 25. So that's the second derivative. That's the first part of part B, first answer. The second part just says to determine whether your answer is underestimate or overestimate. Well, we want to look at this. And we want to look at it specifically at w of 0. And why are we doing this is because we want to find on this graph, specifically where it starts, what is our concavity? What is our concavity of the graph? Because concavity will tell us if it's an overestimate or underestimate. If it's concave up, it's going to be an underestimate. If it's concave down, it's going to be an overestimate. Concave up is an underestimate, concave down is an overestimate. So we find at w of 0, we just plug that in for w. Okay, so you do the math there, and then you end up getting that it's greater than 0. So I guess to formally write it, if I were to simplify all that, I get 1400 minus 300 divided by 625 is greater than 0. So concave up, so underestimate. That was for part B. Okay, part C. This part C was asking to find a particular solution with initial conditions. Particular solutions, we got to be thinking a couple things. We could say, okay, maybe we can look at a graph, maybe a direction plane or a slope field, or separation of variables. We want to find a solution. We've done a ton of separation of variables, and that's what we want to do here. So basically, we want to separate the variables. Start with that. Let's put the w and the 300 on one side of the equation, and then the constant in dt on the other side. So that's the first step of separation of variables. Take the integral of both sides, and I'm left with the natural log of the absolute value of w minus 300 is equal to 1 over 25. In this case, we're going to use t plus c. To find c, we want to figure this out at t equals 0. W is equal to 1400. So this with the LC, that means that the natural log of 1400 minus 300 is equal to 1 over 25 times 0 plus c, which means c is going to be equal to the natural log of 1100. Okay, but the actual question wanted us to find w, if the particular solution, w. So we have to solve for w, meaning that we are going to take this portion here, right here, and we're going to solve for w. Except now we know what c is. So we're going to replace c with natural log of 1100. And then we're going to do some math. So we want to take e to the both sides. So you're going to be left with w minus 300 is equal to e to the 1 over 25t plus the natural log of 1100. 1100 is a horrible number to pick with these absolute values. And then the right side we can break down. This can be the same thing as e to the 1 over 25t times e to the natural log of 1100, which is equal to 1100 times e to the 1 over 25t. And then add 300. So w equals 300 plus 1100 e to the 1 over 25t. That's separation of variables. You guys have seen this a lot in this, especially during quarantine. We've done this quite a bit. Same process every time. Got to solve for C. Sometimes you have to solve for K using points that are given to you. And then always you're going to get an equation for W unless it's given to you. So that's what we call our particular solution at the point 0, 1400. How do we feel about that? Any questions? Anything you guys want me to reiterate? Paper says good. All right. Okay, so next thing I want you guys to do is I want you to get out the 2009 FRQ. So we're going to finish off class with 2009 FRQ. And we are going to do number 2. 2009 FRQ, we're going to do number 2. So again, about 15 minutes, probably less than 15 minutes, so I have time to go over it. You guys might not get through it. I'm going to post the solutions to these assignments on Google Classroom, so you will be able to check your work because I'm going to go through them pretty quick, so you'll be able to see how it's scored and everything. I'll go ahead and get started on that, number 2. It's about a rate of people entering an auditorium for a rock concert. – 2009. Same thing as before, guys. If you guys are done, go ahead and type that in the chat when you get done. A couple more minutes and I'm going to start going over this. As a reminder, I probably should have mentioned this because I don't know if you guys read it, but this is a calculator portion. So if any sort of calculations you need to make, you can use a calculator for. Thank you, Peyton. Okay, so I'm going to start going over this because I know you guys might not be done, but at least you get a good chunk of it. And like I said, for the rest of it, I will be posting the solutions and everything so you can go check on your own. So we got this rate at which people are entering auditorium. So we have this rock concert, people are entering an auditorium. The rate people are entering is given by R. So no one's in the auditorium and the doors open exactly at time 0. So the doors open, they got 2 minutes, whatever it is, to file into the concert. So how many people are in the auditorium when the concert begins? So we got to figure out what time the concert begins. So concert begins at t equals 2. Now the question is how many people are in there at that time? Well, we got to figure out how many people are going into the concert, how many people are arriving, how many people are flooding into the concert. And the only time that they're doing that is between 0 and 2. So if R of t represents the rate of people which are entering, then the integral would be the number of people entering. The integral of R of t is the number of people entering. So we just got to figure out what is the time frame for people entering. It's 0 to 2 hours. So this question boils down to how many people are in the auditorium when the concert begins. It's just based off of how many people enter the venue, which is found by taking the integral from 0 to 2 of R of t. You guys will put this in your calculator. I've done this a couple times. I really would love it if you would tell me how you're doing it, or tell me if you're struggling doing this. Like email me, whatever you got to do. But it's really important that we have some sort of way for you guys to use it to find integrals on your calculator. It's a little late to be like researching how to do that. I've been telling you guys for a while, especially those of you who have trouble with the calculators, to do this. This is super important. But you'll just plug in the function R of t and then evaluate it from 0 to 2, and that's going to give you 980 people. So again, it's all just calculator. All right, moving quick because we're running out of time. Part B, find the time rate at which people enter the auditorium is the maximum. The rate at which people enter the auditorium is found by R of t. To determine if R of t, where there's maximum and minimums, we need to figure out where R prime of t is equal to 0. That's our derivative. So first we need to find R prime of t. This is just a basic derivative. So 1380 times 2 t minus 3 times 675 t squared. I know you guys can do this in your calculator. I'm just not putting it in right away because just for time. So you put that in, you set that equal to 0. What I would do is just to graph this and then look at the time frame from x equals 0 to 2 and just see where this crosses the axis, the x-axis. That's what I would do. You could probably use quadratic formula. It'd be a pain in the butt, but you could do it. Regardless of the method you chose, you're going to get t is equal to 1.363 hours. Now, that's not my answer. My question said, find the time which the people enter the auditorium is its maximum. Well, there's a multiple times. We could have, this is called the candidates test. This is an absolute max, not a local max. It's an absolute max. So we need to evaluate using candidates test R of 0, R of 1.363, and R of 2. Oops. Scratch it. R of 2. Okay, R of 0 is given to us. It's 0. No one's in there. No one's in there to start. R of 1.363 is going to be equal to 854.527. And R of 2 is going to be equal to 120. So again, that's just using the fact that we know what R is. You just plug it into the equation. So your final answer, the biggest value there, is 854.527. All right, let's keep chugging. 2 minutes left. All right, so C, the total wait time for people in the auditorium is found by adding each time person waits, starting the time person enters the auditorium and ending when the concert begins. That makes sense, right? The total wait time is when you get there and you're waiting. They have a function, W, that models the total wait time for all people. The derivative W is given to us. So the rate of change of the total wait time. We want to find W2 minus W1. Well, we know that the integral, this is called the fundamental theorem of calculus. So we've seen this before. The integral from 1 to 2 of W prime of t dt is equal to W of 2 minus W of 1. That's all this question's coming down to at the end of the day, using the fundamental theorem of calculus. If you take an integral over derivative, we use the FTC, and you can find that it's W of the endpoint minus W of the other endpoint. So all I have to do then is to, W prime of t was given to us. I have to just input all of the different pieces and parts of W prime of t, put it in my calculator, and you get 760 is equal to W of 2 minus W of 1. So on average, a person waits. So this isn't, it's not completely done. So that's going to be our wait time. But we want to go on average. How much is a person going to wait? Well, there's 760. Per each person is about 760. And then divided by how many people there are. So there's 980 people. How do we find 980? Plug it in 2. So how many people are actually in there at the given time. And then you find that total wait time for those who enter the auditorium at t equals 1 is going to be approximately 0.776 hours. So on average, people are waiting 0.776 hours. Oh, I'm sorry, I skipped to D. This is part D. I apologize. This was good for, my bad. I was worried about time. This is supposed to be 387.5 hours. I apologize. So when you plug that into your calculator, you get 387.5. The total wait time is going to be the integral. So I'm just going to ignore that. The integral from 0 to 2 of W prime of t. And that's going to be 760. And like I said, to find per person, you take 760 divided by 980. So I know I went through that fast, but it is Algebra 2 time currently. I didn't want to go too far over. So guys, I'll post this, especially those last 2 parts. I didn't really get to talk about too much. I ran out of time. So I'll post the solutions. You guys can work through them. Email me if you have any questions on where they're getting their solutions from, like what it means, how they're getting there. So the test is tomorrow. Make sure you guys get everything set up. study tonight. I'll be up, and I'll be try to be active and engaged. If you guys have any questions from now until like 8 o'clock or 9 o'clock, I'll try to answer them as best I can over email. So please don't hesitate. As you're studying, if stuff comes up, go ahead and shoot me an email. And if not, try to get back to you tomorrow. Okay, if I don't talk to you guys or don't see you, wish you the best of luck. I'll be back on from 1 to 2. Hope you guys have a fantastic day. Stackling, am I able to use Desmos on my phone for integrals? Yeah, there's nothing that says you can't. So I've really been looking. I've been trying to process, see if there's anything that's, in terms of online calculators, they're straying away from. It doesn't look like it. So yeah, that's fine, Stackling, as long as you're comfortable with it. But yeah, guys, good luck tomorrow if I don't see you. Hope everything goes well for you. Appreciate you stopping by. Have a great rest of your day. Yep, you have a good day too, Stackling. Have a good day, Bram. Jaden, good morning. I'm doing good. How are you doing? Happy Monday. How's your weekend? Good morning, Egidio. How's your weekend? Pretty good. Good to hear. Mine was good, Egidio. Relaxing. Mother's Day was fun. I got some food from the pit barbecue. Took it over to my parents' house for Mother's Day. Got to see my mom and hang out with them for a little bit, so that was good. Always good to see the family. Hopefully you guys celebrated Mother's Day and treated your mothers well. I hope so. Maybe got them a gift or did something kind, did some chores for them or something like that. All right, guys, so go ahead and get your calendar up and get the book out. Oh, man. Whew. Found a pretty cool playlist on Spotify I'm pretty into right now, which I'm enjoying. I love when I find music that, like, maybe not necessarily new music, but just like a certain kind of, I don't know, a certain kind of taste that like I've really been feeling recently. So I found some new stuff and I've really been enjoying it. So this weekend, that's what I did a lot. I was playing a lot of music and kind of just chilling. I do that a lot. I don't know about you guys, but like when I study, when I prepare for the school week, when I'm doing just anything like work oriented or my mind's kind of moving, I like to put music in the background. Some people hate it, but for me, like, it helps a ton. If I don't have music and it's just quiet, I go nuts and I get distracted and I don't want to do anything. So like even like when I worked at like a car dealership and the bank and all the other jobs I've had, I've always tried to persuade my bosses to have music on at all times. Just keeps me kind of, I don't know. Like for me, I really love doing mindless things and listening to music. Very much enjoy that. Which is why a lot of times like I enjoy doing like manual labor because you don't really have to think about it. You just do it. You get to especially if you can listen to music and do it, you just kind of, lift heavy things or, move heavy things and that's it. I don't hate that. All right. So Jaden, what page in the book? 575, Jaden. Good morning, Damon. Good to see you. How was your weekend, Damon? Page 575. I listen to music. I have a YouTube video up. Yeah, same here, Sarah. So I did that too. I try to pick YouTube videos where I don't really have to watch, Like I like to get YouTube videos where it's, I don't know, a podcast clip or something like that. I do that a lot. I'll just pick podcast clips or different podcasts I listen to and just like listen to like the highlights on YouTube. I do that quite a bit. Sometimes I'll turn on like they have mixes, like music mixes. So like Two Friends, I don't know if you guys ever heard of them, but there's a band called Two Friends that I like, and they have like different mixes on YouTube. And sometimes I'll listen to those, which is cool. And they have the music videos with them, so it's kind of a mashup. I enjoy that. But if it's something like I want to watch, I'll get distracted. So I try to pick something that I don't have to like pay attention to. Or I'll put on like a TV show like The Office or Parks and Recreation or, Always Sunny in Philadelphia. Something in the background where like I already have seen it and I don't really need to pay attention to it. It's just kind of like some noise and like every once in a while I'll look up and laugh. I like to do that as well. Dan, working a lot, making money. Yeah, that's the truth. Not ideal because you got a lot going on in your life, but it's good to be busy, and especially when you're making money, it's well worth it. I feel that. Yeah, so guys, page 575. I'm going to talk about our calendar because for you guys, you actually have a normal week. Let me see. Well, you know what? I'll tell you what. I'll ask you guys. Now that you guys are all in this chat, I think this is going to be useful. So, if you look at the calendar for this week, here's what we got going on. Let me show. Oh, I'm showing my face. Hey guys, sorry. I was showing my notebook this whole time. So that's personal when you're just looking at a notebook and some human voices in the background. Anyways, here you go. I think I'm on my screen. Yeah. All right, here's a calendar. This is what we got going on for us. Today we're going to do 8.6, and Wednesday we're going to do 8.6. So 8.6, 2 weeks in a row. Again, I know like other Algebra 2 classes aren't taking this much time on it. I'm doing it because this is a weird situation, obviously, with quarantine. I want to make it clear 8.6 is, like, in my opinion, a super important unit. This stuff is working on so many skills and a lot of review, and like putting that all together, I think this is just a really beneficial chapter to do and to focus on. So I'm going to spend another week on it. Today we're going to take actual notes. So briefly, we're going to talk about just solving inequalities. We've been solving equations of rational expressions. We're going to be solving inequalities of rational expressions today. And then your homework is actually going to be rational equations. So your homework is only going to test you on equations, not even what we do today. I just want to show you what inequalities. It's very, very similar. You guys have done this before. So it's really just extra practice, but with a different symbol in the middle. Instead of equals, it's going to be inequality. So that's what we're doing today. Wednesday's going to be an 8.6 review day. So it's going to have a couple word problems. It's going to have inequalities, and it's going to have equations. And we're just going to work on 8.6 on Wednesday. The plan is we're just going to take we're going to get it through as much as we can, basically, of 8.6. So there's two options. We'll figure that out on Wednesday. Maybe think about it, though. Either you guys can work on it, and as you go, I'll just be here live, and I can just answer questions as we go and go over stuff as you guys work. I can go step by step through stuff. We can do the word problems first, get those done, and then do the rest. There's a bunch of different options we can take it. So Wednesday's kind of up in the air. However we want to handle it, we'll handle it. as long as by the end of the week the assignment's done. And so then you'll post that to Google Classroom for a grade. Friday, as always, optional stream. If you guys need questions answered, hop in. What I do want to ask you guys, though, because I know, Jaden and Sarah, especially, you two are always here, and you guys are always communicating with me and engaging, so I'm going to ask you, and Damon, I see you as well quite a bit. So I guess for you three, and I know Haley Mayer's often here, she just doesn't say much in the chat. So let me ask you guys, Calculus is taking their AP test on Tuesday. So there's the AP Calculus, both of my BC and AB, they're all taking their tests on Tuesday, which means that they have other AP tests as well. So they're taking, I think they have 3 or 4 this week. So they got quite a bit going on. So they're done with Calculus on Tuesday and their math class. We're going to still do some stuff, but the stream-wise, it's going to change. I don't even know if I will stream anymore for Calculus. We'll see. Maybe I'll just have a stream just for fun, just to say hi to everyone. But now until the end of the year, I don't really know how much we'll be streaming with them. With that being said, that means the only stream I'm going to be doing is with you guys. And that's actually going to end, by the way, the 22nd, I believe, is the date. I have to check my calendar again. The 22nd sounds right. I'm going to look at my phone real quick. I'm not texting, just looking at my phone. Yeah, 22nd. So 22nd, which is in a couple weeks. So we have all this week and then next week. So this week and next week. 22nd is we're not done with school, but I'm done with teaching new content is what's happening on the 22nd. So there's no point in me streaming if I'm not going to be teaching anything. That whole point of that time frame, so from the 22nd to the end of the school year, is called remediation. Most of you in here, I can't say all for sure, but I know most of you are going to be okay after that. You won't really have any remediation because you're here every day. I know you know the content. You're turning in your assignments, doing good on the assignments. Grades fine. No remediation needed. Your school year's done. Some people are not going to be in that boat, and I'm going to handle those people individually for the most part. So anyone who has to be in this remediation process, I'll reach out individually, and we'll work times. If they need me to stream, I'll stream for them. Whatever. That's not your concern, though. That's for them. So moral of the story is 2 more weeks of this streaming for pretty the normal streaming. But in these next 2 weeks, what I would like to know is, do you guys want to continue with the 11 to 12 time frame? I'm not saying make it 11 till 2 in the afternoon. It's still going to be an hour. We'll just do an hour stream still. That's not going to change. But would you rather have it at 9 in the morning till 10? Would you rather have 10 to 11, 11 to 12, 12 to 1? I kind of like my 1 to 2 office hour time, so I'm going to keep that. And I don't want to go too far into the afternoon. I could probably do 2 to 3, but I would prefer not to. So yes, meaning you guys are okay with the time frame I have now, 11. Okay, cool. Yeah. All right. That's what I wanted to check with. All right, so then I'll just keep that. I'll keep 11 to 12. So I won't have a stream. I'll start the stream with you guys. So it'll only be the videos on YouTube will be an hour long, just of your stream. Yeah, and I guess it's really just the rest of this week. So next week, I'm not going to start a new chapter. So next week, I don't know what I'm going to do, honestly. I might just do some random review, some fun review. Shouldn't say I don't know, might not be fun for you, but I have fun with it. So I would just maybe maybe I'll think of something. I'll figure something out. Sarah, you still off for that Zoom meeting? Yeah, maybe a Zoom meeting would be I'll think about it. Do you know if we can get things out of our lockers? That's a great question, Jaden. I don't think so. I know you can't right now. The answer is no currently. Whether or not you'll be able to at some point, I don't know. The issue with someone going in there is it completely jeopardizes everything. So you would have to re-sanitize everything. I don't see it happening. Sarah says nope. Sarah probably has a good intel because her dad, so she probably knows just as well as I do. Yeah, I don't foresee a situation where that's going to be possible this year. You never know though. If there's something super important in there, Jaden, for you, if there's something like really super important in it, maybe you could find a solution to a janitor to go in there and get it for you, and then you could come pick it up. I don't really know. You have to consider that. Yeah, so I would consider the importance of whatever you need, Jaden. If it's like super, super important, I don't know what would classify as super, super important, but if it's for you, if it's like sentimental or something you need, reach out to some sort of administration, or your guidance counselor probably would be the best option. Reach out to your guidance counselor and ask if there's any way you can arrange to have someone pick it up for you and then you can pick it up. That's my advice. Okay, cool. So we'll keep it 11 to 12. Like I said, for most of you, this normal thing we've been doing every week will end after next week. So next week will be the last week of our streams. Maybe on a Wednesday or something, our last stream together, maybe I'll do a live Zoom or something. I would enjoy that. I don't know who would show up. It'd probably just be you two, but maybe if I marketed it, more people would want to. I just got to decide what I want to do for it. All right. So, I think that's all I wanted to say. Sorry, I was just kind of Hangman. Yeah, I think we'd probably do some Hangman. Maybe like just from maybe we could have like maybe we have a fun Zoom. Hangman we could play, and then we could do maybe do like trivia or something. Not like math trivia, just trivia in general. You know, something like we'd have like a fun day. We'll see. Okay. I think you guys still see me. Yeah, perfect. All right. So today, inequalities, rational equations, or rational function inequalities. That's what we're working on. Just one page. Shouldn't be too much. So to solve rational inequalities, which are inequalities that contain one or more rational expressions, follow these steps. Animal Crossing. Knock it off with the Animal Crossing. I'm not an Animal Crossing guy. That's not how I roll. I'm not live streaming any Animal Crossing. It would be funny though. All right, so when we're solving these, state the excluded values. These are the values for which the denominator is 0. So you always got to establish that. That's really important, guys. Let me ask you, and you can answer in the chat, what does it mean? Oh, wait, darn it, never mind. Sorry, they gave you the answer. All right, so an excluded value is when the denominator is equal to 0. Okay, here's my question. What is another name for that? So let's say that x equals 2. Let's say that's an excluded value because that makes the denominator 0. What do we call that? Go ahead and answer in the chat. What do we call that? Undefined. Very true. Very true. Yes, Jaden. So you guys are both correct, and the word I'm looking for is it is a vertical asymptote. That was the big word I was looking for. We call it a vertical asymptote. Wherever the denominators, whatever x value makes the denominator 0, that's what we call a vertical asymptote. And it's undefined there, correct, Sarah? And it's also, the denominator of the fraction is 0. Also true. All right. So just vocabulary. I'm just trying to mix in the vocab, make sure we're using the correct vocabulary. You guys will see asymptotes all the time in pre-calc when you get there. So this is the steps you're taking to solve these inequalities. So your first step, find those. Pretty easy. You just look at the fractions to start the problem. Step 2 is to solve the related equation. So remember, this is what we did when we're solving inequalities. We changed the inequality to an equal sign. So you go through, set it equal, and then that's just the same process for solving a rational equation we've been doing for the last week. 3 is to use the values determined from the previous steps to divide a number line. So we've done this before as well. We're going to make a number line, and we're going to split the number line into those sections, into our excluded value, or our asymptote, and our two solutions. So we'll split up the graph into all those, and we'll make little vertical lines on those. And then step 4 is to test a value in each interval to determine which intervals contain values that satisfy the inequality. So you'll go all the way back to the original inequality, pick random values of x that fall in these intervals. If it makes the statement true, you shade it in. If it makes the statement false, you keep it blank. You don't shade it in. All right, that's the process. So let's get started on number 1. Let me change over to my book so you guys can follow along. All right, so this is example. I really can't write today. I mean, I never can write well, but today especially, I don't know what is going on. It's like my brain and my hand are not on the same page at all. So bear with me. I'm going to try to take my time a little bit. So I'm just going to copy down this inequality. X divided by 3 minus 1 divided by x minus 2 is less than x plus 1 divided by 4. Okay, so step 1, find the excluded values. So we got to look at all this. Where is any of these denominators of these rational expressions, are any x values going to make one of these denominators 0? Okay, clearly 3 is always going to be 3. That'll never be 0, so ignore it. 4 is always going to be 4. It'll never be 0, just ignore it. This is the one we have to worry about. What value of x makes x minus 2 0? Well, 2. So this is what we call a vertical asymptote. That's our excluded value at x equals 2. All right, not bad. So that's your first step. Don't even touch the equation or inequality, just find the excluded value. Step 2 is to solve by changing the inequality into an equation. So I now write x divided by 3 minus 1 divided by x minus 2 equals x plus 1 divided by 4. And I go through and I solve this. All right, so I first need a least common denominator. And my least common denominator in this situation is going to be 3 times 4 times my other denominator, so x minus 2. So the common denominator they all have, or the least common factor they all have, is going to be all of them being multiplied together. And that's going to be very, very common. So when you guys are trying to find the common denominator, very oftentimes it's going to be just every denominator multiplied together. So now we're going to recreate our equation with our least common denominator. So we are going to draw a little arrow. 3 times 4 is 12, by the way. So 12 times x minus 2 minus, I'm just going to make my denominator for each of these already. Just start doing that now, because I know they all have to have the same denominator in this problem. So the first one, I have to multiply the denominator by 4 times x minus 2. So I have to multiply the numerator by 4 times x minus 2. So x times 4 times x minus 2. This one I have to multiply by 12. So my numerator just turns into 12. This one I have to multiply by 3 times x minus 2. So I have x plus 1 times 3 times x minus 2. And that's probably a good way to write it, using parentheses like that, just to show that they're all being multiplied together. So remember, whatever you multiplied to get to the denominator change, you have to do the same to the numerator, because we can't change the values. All right, and now I can ignore the denominator. Since they're common denominators, the numerators all have to be equal. The statement in the numerator has to be equal. So I have 4x times x minus 2 minus 12 is equal to, I'll just keep the whole thing like this. So that's eliminating the denominator. And now I have to do some simplification. So 4x times x minus 2 is 4x squared minus 8x minus 12 equal to 3 times x plus 1 is 3x. 3 times 1 is 3. So 3x plus 3 times x minus 2. One more step of simplification. 3x times x is 3x squared. 3x times negative 2 is negative 6x. 3 times x is 3x. 3 times negative 2 is negative 6. So that's just using FOIL. I think you guys, I know I should know this, but I don't know if you call it FOIL. But front, outer, inner, last. That's our FOIL method. Okay, now eventually, right, we need to solve for x. That was the whole point of doing this. We want to solve the inequality. So we got to get x. We're going to subtract 3x squared from both sides, so I get x squared on this side. I'm going to combine negative 6x and 3x to get negative 3x and add that to the other side. So negative 5x. Then I'm going to add 6 to the other side. So minus 6. Why did I do that? Because solving quadratic equations, right, we want to set it equal to 0. Always want to set it equal to 0. So x squared minus 5x minus 6 equals 0. To solve a quadratic equation, you factor. Sometimes you need to use quadratic formula. In this case, we don't. A is 1. Outside of x squared, the coefficient is 1. So all I'm doing is looking at this, and I say, what multiplies to negative 6 and adds to negative 5? Well, the answer is x minus 6 times x plus 1. Which means x equals 6, and x equals negative 1. Okay, so I know I did like a lot of work, and you guys might have been fine with that whole process, and I just did way too many lines, and which is true. I did take this step by step, but I figured the first problem I might as well. It's good review anyways. So that's all step 2. You can shorten that probably a ton, but that's what I got. All right, so I'm going to flip the page over to step 3. I'll give it a second just to make sure you have everything copied down. I went pretty quick. Okay. Now we're on to step 3. And step 3, whoa, I don't know what I did there. Step 3 is to create a number line. Okay, and on that number line, we are going to put our vertical asymptote or our excluded point, and we're going to put our solutions. So, if you guys look back, we have negative 1, 6, and 2. So I'm going to put negative 1 here. I'm going to put 2 here. I'm going to put 6 here. And what the book does, you guys don't have to do this. You can kind of choose the way you want to do it, but what they like to do is put like these little lines, little dotted lines, and they're doing that just to show you that these are the separate intervals. So one of my intervals is negative infinity to negative 1. Another interval is negative 1 to 2. Another interval is 2 to 6, and 6 to infinity. Okay, and then step 4 is test the values on intervals. So I'm going to take my original inequality, x divided by 3 minus 1 divided by x minus 2 less than x plus 1 divided by 4. And I'm going to try values. All right, so the first value I want to try is something left of negative 1, and it's going to be y equals x equals negative 3. You can choose whatever you want. It could be negative 100, it could be negative 1,000, negative 2.7. It's up to you. I just would suggest make your life as easy as possible. So I'm going to plug in. I'm only going to do this once. I'm going to plug in negative 3 in for everywhere I see an x. I'm not going to keep showing that step. But just so you know what I'm doing when I say try x equals -3, I'm just plugging in -3 into that. And the book did the work for you here. You end up getting -4/5 is less than -1/2. Is that true? 100% it is true, which means that I can shade in left of -1. Those solutions are true. Okay, and I'm going to go through this a little bit quicker now because the book did the work for it. So now I need to try an interval between -1 and 2. X equals 0 is a perfect choice. You end up getting 1/2 is less than 1/4. Well, that's not true. 1/2 is not less than 1/4. So leave that blank, that interval. Sometimes you'll see me just do this. I'll put a big X. Just signifying, nope, that's not a solution set. Keep going between 2 and 6. Let's try x equals 4. It's a pretty good option. Okay, and x equals 4, you end up getting 5/6 is less than 5/4. 100% correct. So I can shade in between 5 and 6. And then last interval, they try x equals 8, and you get 30 divided by 12 is less than 27 divided by 12, which is just not true. So that interval doesn't count either. Just going to box those out so you can separate them. Okay, so now my number line kind of tells you the answers, but let's formulate. Oh, I'm sorry, Sarah. So where did you get a 2 from? I'm kind of lost. Oh, wait, never mind. Okay. So this gives you your answer. I'm going to write my final answer just at the top. So based on this number line, my final answer is x is less than -1. All these blue shaded to the left of -1 is represented by x is less than -1. And 2 is less than x, which is less than 6. Okay, so I want to ask you guys a question. Well, first of all, before I ask you the question, any parts of that confusing? Was there anything? I know I went there very slow. I took my time. It looks like a lot of work, but it's because I went so slow. Any part of that need to be reviewed again? I want to tell you guys that this step right here, step 4, you don't have to write that out like that. In other words, what I would recommend doing is just say what values you tried. So try x equals -3, try x equals 0, blah, blah, blah. Do that. And then just write your inequality right after that. So no need for that intermediate step of you plugging it in. Just throw it into your calculator and then tell me if your inequality is true or not. In fact, I would take full credit if you just say try x equals -3 and just give me a check mark. That tells me that in your calculator you checked it and you found out that it is true. So if you have any questions, let me know. If you don't, just say good or thumbs up or okay in the chat. Oh, hey, Aiden. I didn't know you were here. Okay, so I want to ask you guys something real quick though. This is the exact breakdown of these problems, and you'll do the same process every time. Only thing that can change is your answer. How come this answer just had this interval was only less than, not less than or equal to ever? Like, why was there ever not like x could be less than or equal to -1? Why did I not check that? Why was that never an option? What do you guys think? Yep, exactly, Jaden. The original question. Look back at the original statement. The original inequality does not have less than or equal to. We found that -1 and 6 make this equal, make this statement equal, which is great and all. Like, good for us. I mean, it helped obviously with our intervals, but because of that, that's when they're equal. This is just a less than, not less than or equal to. So there's no way I can ever have that up here for your solution. So remember that. If you ever have a starting inequality that's just less than or just greater than, your answers are always going to be just less than or just greater than. Now, if it's a less than or equal to, you have a different story. And so we'd see problems like that. We're not going to see any today, but we could see problems like that at some point. Okay, so since you guys don't have any other questions, let's do guided practice 6A. So GP 6A. So I'll give you guys about 10 minutes. So you probably don't even need that long, but try to see if you can get done in 10 minutes. And then I want you to write your answer in chat when you're done. So this is guided practice 6A. All right. Well done, Jaden. Well done. Give a couple more minutes for potentially Aiden and Sarah and Damon if he's still here. Sarah, you're stuck? Go ahead and describe where you're stuck at, Sarah. All right. Step 2. I keep doing something wrong. I can't figure out. Okay, cool. No worries, Sarah. We'll get it. Aiden, same with you. What step are you stuck on, Aiden? Step 2. Okay, cool. All right, well, that's good then. Let's start with step 1, first of all. Step 1 is to find where the vertical asymptote occurs. If you look at the inequality, the only place where the denominator would be 0 is when x is 0, because that first fraction, if x is 0, denominator is 0, and then 5 times 0 would be 0, so the second fraction as well. So you have your vertical asymptote, or your first excluded value, is x equals 0. All right, I'm just going to highlight that in blue. All right, second step. And this is the most important step. So this is good that we're going to get, this is going to be what your homework is going to basically be over. Is this step right here, which is just solving the equation for x. So we got to decide again, what's my least common denominator? Okay, and I think this might be maybe where some issues are having. So I know 3 is on its own. I know 3 has to be part of my least common denominator, because you'll notice that these both have x's. This one is just 3 by itself. So I need a 3 somewhere in there. And then between x and 5x, what's their least common denominator? Well, it's 5x. You multiply this by 5 to get there. So my total least common denominator is 3 times 5x. Okay, which is equal to 15x. 15x is my least common denominator. All right, so continue on with step 2. Make a little arrow. We got to somehow rewrite these. So every single time I'm going to have a 15x as my new common denominator. So each one of these fractions is going to have 15x down there. All right, in order to get from x to 15x, I multiply the denominator by 15. So I also have to multiply the numerator by 15. So 5 times 15, I should know what that is, but I'm lazy. 75. So 75 is in the numerator. To get from 5x to 15x, I have to multiply the denominator by 3. So I have to multiply the numerator by 3. 6 times 3, 6, 12, 18. And then to get from 3 to 15x, I have to multiply by 5x. So I have to multiply the numerator by 5x. 2 times 5x is 10x. All right, so then what I'm left with is 75 plus 18 equals 10x. 75 plus 18 is 93 equals 10x. So 9.3 is equal to x. And that's step 2. So Aiden and Sarah, I would love to see or hear from you. What was the problem with step 2? Where did you go wrong? What gave you problems? Give me a little feedback on step 2. Did you find what you did wrong? Or did you do nothing wrong and you just thought you did something wrong? No, yeah, you were good, Jade. Well done. It looks like your answer is definitely correct, so all your work must have been good. I did the wrong LCD. Okay, so I'm guessing you might have multiplied them all together. So you might have did 5x, 15x squared, which I think you would have still got the same answer, though. Let me see real quick. Let's say, okay. I'm just gonna do this on the side. Completely ignore what I'm doing. I'm just doing this for my own sake. So let's say 15x squared was your, so that'd be 3x plus 18x equals to 5x squared. So 5x squared plus 21x, sorry, 5x squared minus 21x would be equal to 0. Oh, and then you have to do the quadratic. Sorry, guys, I'm going to keep going. This makes it a lot harder, but I think you're still going to get the same answers. No, you're not. Okay, so you'll get a different answer. So yeah, you got to make sure that we do have a correct least common denominator. So it's got to be the least common denominator. So be careful with that. Unless I did. Oh no, actually, no. You'll get the same answer. I just did this wrong. I was going too quickly. I forgot to do the right side of the equation. So yeah, I would double check your work. Yeah, my recommendation is stick to just trying to get the smallest possible denominator that they all multiplied into. The least common denominator, obviously, right? From there, though, so let's keep going, Aiden and Sarah, from your point. So we have 0 and 9.3. That's going to be, that's step 3, is just doing that. Step 4 is actually try values. So you can try x equals -1, I would do. I would try x equals 1 for sure, and I would try x equals 10. Those would be the 3 values I would choose to try, but you didn't have to do those as long as they fell in there. So what you end up finding, let's do -1. You end up getting -5 minus 6/5 is not greater than. So I'm just going to put a big ol' X. Nope, doesn't work. At 1, you're going to get 5 plus 6/5 is greater than 2/3. Yep, that's true. So that works. So I'm going to shade the middle there. And then at 10, you're going to get 1/2 plus 6/50 is greater than 2/3. No, it's not going to be greater than 2/3. It's going to be close, but not greater than 2/3. All right, so your final answer, to kind of put it all together, this interval right here is x is less, or x is greater than 0, but less than 9.3. That's what that little interval in between is. Okay, any questions on that, guys? And if there's no questions, that's the end of the stream. Like I said, the homework is going to be Khan Academy. It's more so step 2. That's basically what it is. Homework is basically step 2 is what you'll be doing. So not all the number line, everything, but we'll see the number line on Wednesday. So we'll do some, in the study guide, we'll be doing more problems like that. Hope you guys have a great rest of your day. I'll be here for the next 2 minutes. If you have any questions, go ahead and keep typing them out. But thank you for stopping by, you people who have communicated with me today. You too, Aiden. Appreciate it. Thank you. See you Wednesday, Jaden. Appreciate it. Have a good day, Gidio. I'll see you guys all. I'll be here 1 to 2 again. If you need any help on the homework, I'll be here. See you.